Hello, my name is James Halderson, and I'm going to do another devlog on the blockchain that I'm working on. So, this will be a more comprehensive look into the blockchain this time. First of all, we're going to go through the functions that we have added here, because I've added a few extra functions to the blockchain. So, we had what we had last time. We have adding, we can see them, we can make wallets, we can load wallets, we can visualize how many wallets there are in the currently locally to the machine. I've added transactions, I've added tokens, and then we can look at token wallets to see what kind of tokens are in each wallet. And then we also have a test version of the ETS, which is the Elastic Token Standard, which is something that I'm working on in theory, and we'll go over that as well. So first, type C, and this will let us see the whole blockchain up to this point. As you can see, I've done all this stuff on the blockchain all the way back up to when I was just putting random data in here. This is all transactions. So I started a new one. Here's the Genesis block here. Wait, here's the Genesis block. Where is the Genesis block? Here's the Genesis block. Okay. So we started with the Genesis block, and then I've done all these test transactions. At first, the transactions were just a balance. There was no token involved. Just random numbers floating out there in the ether and sending those back between these two wallets. So that happened there. All these are just test transactions until about here, where I started to work on actually making a token. And that's what I will demonstrate today. This was my first token, sending it between two different wallets. But as you can see, these are all true. Every single transaction that has been signed to the blockchain is true, which means that the blockchain is currently still working. Even with all these different types of data being hashed to the blockchain, it still works. Okay, so over here, this is where I will be having my wallets. But right now we don't have any. I've deleted all the wallets so I can start again and show the whole process. We do have the blockchain JSON here inside of our documents file. So this is the JSON version of all the blocks on the blockchain, from the Genesis block here. This is the Genesis block. All the way down to when I started to add tokens to the block. So each one of these hashes is just information, transactions being hashed to the blockchain. And that's in JSON format, because JSON format will be essential when we start to add the web functionality and doing a peer-to-peer network, which will be coming up next after what I will demonstrate today. So let's get back into this. Okay, so we're gonna make a wallet. So first of all, to make a wallet, you gotta make a new password. So I'll just say 1 2 3 4 5. That'll be my password, 1 2 3 4 5, and that has created a wallet. So if I go back over here, there should be a wallet. This is the wallet that I created. Inside here, here's my password, 1 2 3 4 5. No tokens yet in the tokens contract, but it has a private key, public key, and address. So that'll be stored locally for now inside of this JSON file. These JSON files will also, I should mention, be encrypted. So I haven't implemented the encryption part yet. The blockchain itself is encrypted hashes using cryptography. But these wallets themselves will be encrypted. So when you make a wallet, it'll be encrypted, and then it'll save your key locally. And then when you open it up through the application, that will decrypt the file to bring in your tokens. And then when you're done transacting on the blockchain, it'll encrypt it again. So that's coming. That'll be in the near future. So we made one wallet. We should make another wallet here, because we're going to add a token, the whole thing. So we'll make another wallet. This one we'll say ABCDEFG. That'll be the password. ABCDEFG. So we've got another wallet now. Should look over here. Is this our new one? ABCDEFG. So we have two wallets now. Both wallets have no token contracts or anything in them. They're both just blank wallets that I've created. So now we want to make a new token. So we're going to go and make a token inside one of these wallets. So what is the name of the token? Let's call it test. Symbol of it will be test. Enter the value of the token will be 1, so this is essentially $1 per token. Enter the initial supply, we'll say 1,000,000 of them. Does the token have a fixed supply? So this is a true or false boolean, so we'll say true, it's a fixed supply. Enter the address token of the token owner. So now we're going to grab one of these. I guess I'll take this one because it's the nearest. And this will be the owner of the token now. So the 1,000,000 tokens will be created and they'll be deposited into this wallet when the token has been created. Okay, so here's the creation event, the token creation event. So the token has been created, a new block was added to the blockchain. The most recent block contains a token creator, and the token ID is this. So it has a token ID. The block hash is this, the block previous hash is this, it was signed by this and by the Genesis block. And the block, or no, sorry, yeah. And the blockchain is true, valid. So that means that there's a new block that has been added to the blockchain at the bottom here. That is the token creation event for this new token that we have just created. And if we go back to that wallet, we can see in this wallet that we do in fact have a token in here, token contracts. So we have a new token contract in here, we have token ID, test. So this is just testing the name of the token, and token symbol. This is the symbol that would be on an exchange or something like that if you were trying to purchase it from external to this blockchain environment. You would be looking for this token symbol on whatever website. So we have a token supply here, and the token balance is the same as the supply because I created the supply, so I've got all the tokens in my wallet. And the token owner is me. It's a fixed supply, true. So we have a token that we have now created. So now that we have a token created, let's try giving some of those tokens to another wallet. So we'll do a transaction now. So transaction has changed to be using tokens. So the address that I want to send funds from, that'll be our wallet here, that this is the owner of the tokens. So this would be like if I was buying the tokens from this wallet, this is how it would happen. So it would go and it would try to get the tokens from this wallet. Which token would you like to send? We have test in there, so we'll type test. And the wallet that we want to receive funds to. In here we can see that there's nothing, no token contracts at all. So this other wallet here that we created, we're going to take that address. The file name is the address, by the way, that's why I'm doing that. And enter the amount of the deposit. So we had 1,000,000 in there, let's say 5,000, we'll say. So this should be a transaction right here that has now taken 5,000 from the creator wallet and put it into my other wallet. So we have a new balance of 995,000, and we have 5,000 in here. Block index, so this is the previous hash, here's the hash from, here's the hash, here's the previous hash, and then these are the two wallets that signed it, which is our two wallets that we just created. And the blockchain is valid as true. So that means that if we go back to this JSON, here we can see that after the token creation event, we now have a transaction event between two wallets. So that's good. This is everything's working fine and dandy right now. This is exactly what you would like to see from a blockchain. Okay, so we have tokens. We've created tokens programmatically using the blockchain. We've transacted between two wallets that we also created using the blockchain. All those wallet creation events, token creation events, are signed to the blockchain, so that you can go and look back and see whenever something like that occurs. We can go and see and check who it was from. There's a timestamp, how much was there sent, how much was there received. All of these will all be on the blockchain. So the last thing that we're going to show off here before we look at some of the code, this is the ETS. So the ETS is the Elastic Token Standard. The Elastic Token Standard is a concept that I came up with for how to reduce volatility inside of the cryptocurrency market. Basically, the idea is that I'm taking 10 of the most popular cryptocurrencies on the market right now. I'm adding them up and I'm getting an average. So this first thing here, the average price of the top 100 coins, this is actually the average of Bitcoin, Ethereum, of Cardano, of Solana, of Dogecoin, of all the most popular coins on the market. The initial price of the token is on this number, and I divide it by a factor of 100,000. So I'm getting 7 cents right off the bat. The current token holdings is 1. There's only 1 in there. Okay. The value of this token is this. The total supply is this. And the adjusted token price is then tiny, puny, right? Because each one of these tokens multiplied by this number is going to equal out to $1. So the token holdings, what this actually represents is how much money I actually have. So let's look at the code for that. So we're going to go all the way down to the bottom, and we're going to look at the code for this. So here, the first thing that's going on is that I'm using CoinMarketCap as my client for my API call, and I'm just getting all of these tokens, and then I'm averaging the price of those tokens to get the 72,000, which is what the average of all those prices right now would be. And that's because Bitcoin is so much higher than all the other coins that even though most coins average between $100 to $300, the Bitcoin being that high in the near 70,000 actually augments the price by that much. So the average price of the top 10 coins is the average price, and then the token price is that divided by 100,000. The initial price of the token is this number here, this divided by 100,000, and then my token holding, let's say that's $1. So every time somebody buys a token from the ETS standard, that would then go into a token holding. So it's the actual market cap of the token. Each time somebody purchases a new token, it will be added to this number. So we could say that if, imagine there was $1,000 in here, inside of the token holding here. The token supply is then calculated based upon the token holding divided by 1,000 times the current token price. So this calculation I came up with is actually going to go then readjust the token supply by the token holding divided by this times 1,000. So what this is essentially saying is that every time more money is added to the system, this will generate new tokens to compensate for that value. And if money is taken away from the holding, so if somebody was to sell these tokens, then the total supply would also adjust in a negative direction so that this price point can remain very stable. Because what we're doing here to reduce the instability of cryptocurrency is because I'm taking the average of all of these coins. It's like an ETF, or it's like a diversified stock portfolio. There's so many different factors in play here, and then I'm only taking like 100th of 1% of all of this, or 1,000th of 1% actually of all of this as the price, and I'm adjusting my price by that. So if this goes way up and this goes way down, that is minimized because I'm only taking 1,000th of 1% of that and using that as the base point of my calculation here, of my algorithm. And then the token holdings, we generate more coins based upon this price point. So the more money you put in, this vehicle actually has room to grow in a positive direction. But at the same time, if it goes down, if these all go down, this price will remain relatively stable. It could go down. Like, for this to go down, these prices here would have to, you'd have to lose billions and billions of dollars, or even hundreds of billions of dollars overnight. It would have to go away for this number to be affected in any drastic direction. So this is the ETS, and in theory, this should reduce volatility in the market. So let's look at this now. Since I changed this, we'll reload the app here. And we'll look, I put 1,000 in here of my holding. So imagine I put $1,000 into my own token instead of $1 there. And we'll look at the ETS standard now. So this is going to take a few seconds because it has to calculate and get everything from the API. So the average price is now 7.1, so it's actually gone down significantly, right? This number has actually dropped down significantly. It's lost a whole, what is that? It's lost almost $100 since I last calculated it a few minutes ago. So, but my number, even though this has lost $100, and if you had money inside of here, you would have lost a huge percentage. Here, it's still 0.07. Now it's just 0.7 and 1/10 of a cent. I have 1,000 tokens in here, and this will be my supply for that. So if I calculated this supply multiplied by this new price of 7 cents, at this point it would be 7 cents with $1,000 in it. Each token would be 7 cents. I multiply this by that, and I should get to 1,000. Or somewhere near 1,000. So that's the ETS in action. Let's see what it would be like if you had $1 million. So if you had $1 million inside of this system. We'll type ETS, we got to calculate it and get the API call. Here we're doing the API call, we're getting it. So now, if you had $1 million inside that system, you'd have a size this big of supply, and each token would now be worth $71 each. So that's the thing, right? Because what's going on here is that there's $1 million in here. That doesn't mean that every single token here is in circulation. This is just the total, the total of all tokens that can exist. So if there's $1 million in the system, this is how many tokens can exist. There's $71 per token with $1 million in the thing. So as you can see, we reduce the volatility because this number here isn't changing very drastically. This number would have to change by a huge amount for this number to change by a little amount. If we put all this money into this system and it's still augmenting this number here, then we still have room to grow from when I had $1 and it was fractions of a cent to if there was $1 million in it and the coin would now be worth $71 each, while creating this supply, this massive supply that it will always get bigger and bigger and bigger as long as money is entering the system. There's no way that this supply could ever be reached in theory. And that's a good thing because the circulating supply will never meet the total supply in circulation. The market cap can grow to billions of dollars and this number will never be reached. And if everybody sold off at once and we were at $1 million and all of a sudden everybody sold off and it was only worth $1, ETFs, just calculating it here, there's still a huge supply of these available. It would still be available. So because of that, what this achieves is that liquidity is the problem with cryptocurrencies in a lot of cases. What this does is this ensures that there's always liquidity, always enough liquidity to liquidate the tokens, no matter what. No matter how much it grows, it'll generate more tokens to match the liquidity so that there's always enough that I can sell all my tokens, because the total supply is based on how much money, how much USD is actually in the system. If there's no USD in the system, then there's no tokens in the system. But because there's one token in here right now, $1 worth, there's tokens being generated by the system. There's this many, 139,056.99 that are generated for every $1 that's inside the system. And they're worth this much each. At this point, if there was $1, this is how much they would be worth each, those tokens. So that's the Elastic Token Standard. Basically, it's changing the supply to adjust the price of each token so that it's always liquid. There's always a way to have liquidity. To avoid volatility in the market is another benefit of that. And the third thing that is great about doing it in such a way is that it's not volatile whatsoever. There's always liquidity available. Basically, that's the only 2 points you really need. So that's the concept of ETS, which I've explained more on social media or whatever, about the concept of this and why this is a good vehicle for investment, why this would be a good investment vehicle. compared to other cryptocurrencies, because it avoids that volatility, because it is always liquid, because it generates new tokens based on how much USD we have. These are all three big selling points of why the Elastic Token Standard, the ETS, is going to be a great thing for cryptocurrency. So that's about it for the functionality of the app. To be a little more comprehensive, we were looking into some of the code here. I mean, we could dive into some of the other code, but that's, I mean, I'll put this video out, and then if people want to look into some of the other code in here that I've written of how I'm achieving these calculations and everything, because I wrote all this code from scratch. This is all my code in C#. By the way, this is one of the, there is a C# based blockchain called Stratus right now, but I did this from scratch. This is all me. I created this blockchain 100% from scratch. It's C#, which means that it's very extensible. People will be able to program their own C# scripts and be able to very easily implement it into this. And the other thing about C# is that it gives me the ability to do a continuous development cycle. So once I put this out, once this blockchain is actually available to everybody, I will be able to fix any bugs or anything. It's not out there. It's not permanent. It's not like Solidity with Ethereum, where you can't change the source code. I can change the source code as much as I want because I wrote it in C# and it's extensible, and it has the capability to be manipulated after. Of course, when I put the code out, it will be obfuscated so that nobody can just manipulate it. It's going to have to come back to me, and I'll have the obfuscation codes and everything in order to be able to manipulate the code again. But that's about it for now. I'll put this video out. If people want to know more about the code and how I'm achieving these calculations, how I'm achieving tokens, creating them, distributing them, doing transactions with tokens instead of wallets, that's all here. I can talk about all that. I can talk it through. If you want to know how the blockchain itself is working, I can talk about the actual blockchain class and how that's working, or how blocks work inside of this environment. Anything like that. But yeah, for now, that's my devlog. A little more comprehensive than the last one was. Went through several new concepts. Next time I check in, we should be implementing the ETS. Instead of just having it as a test token, we'll actually implement the ETS contract here. So I'll implement the ETS contract, and I'll actually be adding it to wallets and everything. That's the next step. And then we'll be working with WebSocket's P2P networks. And after I have that working, then it'll be on to making a wallet application that I can distribute to the world around. So if you want to know more about this, contact me or whatever, either on Facebook, or that's really the only place I'm posting it right now. I might put it on my YouTube, but I'm really happy with this project so far. I'm going to keep working on it. I just want to get it out there and have others look at it and give me their viewpoints and what they think of the ETS standard, because there's other things that I want to add to this that will be very revolutionary for blockchain and for cryptocurrency. But yeah, for now, this is it. So I'll talk to you later.